Hi everyone, in this video my groupmates and I are going to present about the mechanics principles of gutter crutches as one of the real life examples that we have chosen. My name is Nurnadia binti Muhammad Faisal with matrix number KIB2003. So a little bit background to this study. Crutches in one form or another have been used for 5,000 years, which means that people have started to use crutches since a very long time ago. So from fallen tree branches used to assist balance and ambulation, they have evolved into their present configuration of underarm and forearm crutches. They use fallen tree branches to support their balance. So nowadays we can find various type of crutches which suit and meet our demands. In this study, we're just going to focus on gutter crutches. Gutter crutches are designed to aid in ambulation by transferring body weight from leg to the torso and arms, which means that if you cannot use your legs temporarily or permanently, you can use these crutches to support. As a support, this device is mainly used by individuals with lower extremity injuries or neurological impairment, varying from short-term injuries to lifelong disabilities. As you can see from the picture attached, gutter crutches are composed of padded forearm support, strap, and adjustable handpiece with a rubber ferrule. Depending on the patient's condition, some might need only one crutch, some might need two crutches to assist in their walking or movement. These crutches is usually in adjustable length, so for first step you need to adjust the length according to your height so you can walk comfortably with the desired length of the crutches. Second would be place your arm into the designated elbow placement and hold firmly to the holder to provide more support during walking. And third, you can start swinging your legs slowly. We are using the gutter crutch as real life examples because the gutter crutch can help to give a clear view on how mechanics principles work in reality. There are 3 different LOs that are going to be covered in this study. These calculations are basically to ensure the safety of the device to prevent structural failure and eliminate possible risks. All these 3 LOs are going to be discussed by my group members.
Hi and a very good day. My name is Rajan Tasni binti Raja Aisha with the matrix number of KIB190061 or with the new matrix number of 17113595-2. We now start our first learning outcome, which is to solve problems involving a body under the action of axial and torsional load. So since our group has decided to choose the gutter crutch as our real life example, first in my part I'll be analyzing this part right here, which it will be under the action of axial load, and the handle part right here, which will be under the action of torsional load. So our problem statements are, first is that we want to calculate the axial stress experienced by the gutter crutch when 420 Newton is applied. And it can be referred to this free body diagram right here. And second is that we want to calculate the shearing stress experienced at the holder part of the crutch when a total of 15 Newton-meter torque is applied by the user wrist, given the radius of the holder part is 4 cm. So you can refer, this problem statement can refer to the free body diagram here. So for the calculations part, so first is that we want to calculate the axial stress. So as according to the free body diagram, the length has been given as 800 mm and the diameter has been given as 30 mm. So with all the parameters given, we can first now find the value of area, which we obtain 7.069 times 10 to the power -84 meter square, and then we can straight away find the normal stress, which has the formula of force applied divided by area. Then after we calculate everything, we'll get the normal stress value of 0.594 megapascal. So second is that we want to calculate shear stress, which under the torsional load, which is under the action of torsional load. So according to the free body diagram here, torque is given, which is 15 Newton meter. So first is that if we want to find shearing stress, we need to know what the value of J. What is the value of J? Which is the polar moment of inertia, and it has the formula of J equal to 1 over 2 pi c to the power of 4. Then we substitute the values, and this 4 times 10 to the power 82 is what is given as the radius, which is 4 cm, and we obtain the value of J of 4.021 micrometer to the power of 4. Then we can straight away calculate the shearing stress, which has the formula of Tc over J, and we substitute all the value. T 50 mm, this is the radius, which is the 4 cm, and this is the moment of inertia that we just obtained earlier. And then we got the value of shearing stress of 149.22 kilopascal. Thank you.
Hi, my name is Nur Amina binti Muhammad Azali with matrix number KIB2003. So today, I would like to continue the presentation with the learning outcomes 2, where I need to solve the problems involving stress in beams. So as you can see here, this is the forearm support of the gutter crutch, where I need to solve the problems involving stress in this part. Okay. Next is I need to find 3 things, which are shear force, maximum bending moment, and also maximum bending stress of the padded forearm support. Okay, as you can see here, this is the free body diagram of the padded forearm support, where this is the length of the padded forearm support, and this is the weight applied, the force applied by the patient, and this is the shear force and bending moment, and this is the cross sectional area of the padded forearm support. Okay, next is I have made some assumptions, which are the force applied is 420 Newton, where the length and height of the forearm support is 120 mm and 60 mm respectively. And the force applied by the patient is uniformly distributed on the forearm support, and also the cross-sectional area has a height of 60 mm and base of 80 mm. Okay, so for the shear force, I've been using this formula, which are force time length of the forearm support, and I've substituted the formula and I've got the shear force equal to 50.4 Newton. Then for maximum bending moment, I use this formula, and then I substitute the value, and I've got the maximum bending moment is equal to negative 3.024 Newton meter. Okay, last but not least is I need to find the maximum bending stress of the forearm support, and before that I need to find the moment of inertia. I use the formula. I use the moment of inertia equal to base times height power of 3 over 12, is because the cross-sectional area is in the rectangular shape, and I substitute the value, and I've got the moment of inertia equal to 1.44 times 10 power of negative 6 meter. Okay, when I have found this moment of inertia value, and so I can find the maximum bending moment of stress, and I use this formula, and I've substituted the value. C is equal to 0.03 because the height is 60 millimeter, and the C is at the middle of the rectangle shape, which is centroid, and I divide by 2, and I've got 0.03. Then for moment of inertia, I use this formula, and I've got the maximum bending stress is equal to 63 kilopascal. That's all from me. Thank you.
Hi, I am Nur Adrin Yasmin binti Zawanadi, KIB2003. I will continue the presentation with learning outcome 3. For LO3, we want to evaluate stress and deformation of biomedical devices due to compound load. So in our case, we'll choose gutter crutch, and the part involved for LO3 is only this part, the main part of the crutch. So we want to calculate the stress and deformation of the gutter crutch when 420 Newton force is applied on the crutch. Basically, the force applied came from the patient when he or she used the crutch. So we also have fixed the length and diameter of the crutch to 800 mm and 30 mm respectively. And the crutch is made from aluminum material, so it has the value of Young modulus of 69 gigapascal. So first we need to draw the free body diagram of the crutch first. So here the free body diagram, we have the force applied by the patient, which is 420 Newton, and we have the length of crutch 800 mm and the diameter of the crutch 30 mm. For calculation, we need to calculate the area of the crutch first. So since we have the diameter, we can use the formula of area pi d over 2 squared. So we insert the values and we will get the area of 7.069 times 10 to the power of negative 4 meter squared. And then we need to calculate the stress of the structure. So the formula of stress is P over A. Basically, it's the same as calculated in the axial stress part. And we will get the stress for 0.594 megapascal. And lastly, we will calculate the deformation. For deformation, the formula is PL over AE. P is represented by the force applied, L is for the length of crutch, A is for the area of crutch, E is for the Young modulus. We insert all the values and we will get the formation of 6.889 μm. We're done with all the LOs, we come to the conclusion part. So by doing this assignment, we managed to get deeper understanding on how principle of mechanics involves in biomedical devices. In our case, we chose gutter crutch, and by doing the assignment, we learn more on how actually mechanics involved in gutter crutch. And we also learned that different parts of the device experience different kind of stress. As example, for axial stress, it's only experienced by the main part of the crutch, the stand part, but for shear stress, it's experienced by the holder part of the device. Lastly, by applying mechanics of materials, we can ensure the safety of the device. So we calculated the stresses on the structure. In our case, we calculated the stresses on the crutch. So we can ensure that the stresses are not exceeding the allowable stress. So by that, we can ensure the device is safe to be used by the patient. And lastly, here is our reference. I think that's all from our group. Thank you.